derivatives of inverse functions. So let me just remind you of a couple of things. First of all, that two functions f and g are inverses of each other if and only if f of g of x is equal to g of f of x is equal to x. Right? They undo one another is the way I think about it. Right? Multiplying something by 2 and then taking half. Well, you get back to where you started. Right? Adding 3, subtracting 3. Right? Those are inverses of one another. So the notation for the inverse function of f, well, this must have been decided by an algebra teacher because I hate it. Right? They write f and it looks like it's being raised to the -1 power. Such a terrible choice. Because it looks like, doesn't it look like it's to the -1 power? So this is f inverse. This is how you write f to the -1 power. They are not the same. Okay, and students sometimes will ask, well, if you're so smart, what would you have done? I would have done f inverse of x. That would have been my choice. There are other ones you could have done. All right, so the second thing to remind you of is that if the point with coordinates a, b is on the graph of f, then the point with coordinates b, a will be on the graph of g. The x and the y's switch. You probably remember doing that a fair bit from algebra classes, right? You switch the x and the y and then solve to find the inverse. Okay? So the effect that this has graphically, which is something that you probably didn't do very much, if at all, is that the graphs of f and g are reflections of each other over the line y equals x. So if I start off with y is equal to g of x, and I go through a point that has coordinates b, g of b, then the inverse function of g, f, will be the reflection across the y-axis, and it'll have the point g of b, b, right? Because the x and the y coordinates will just reverse each other. Okay, so we're going to add to this now. So let's say that I draw in a tangent line here. The slope of that line is going to be equal to g prime at b, right? Everybody with me on that? All right. Down here, the slope of this line will be equal to f prime at g of b. Now, since those two are reflections across the line y equals x, we can think about reversing the x's and the y's. Now, when you do slope, it's the change in y over the change in x, right? So that means that g prime at b is equal to the reciprocal of the slope for this line. That is 1 over f prime of g of b. Because the slope of this line is the change in y over the change in x. So if I flip it over, that's the change in x over the change in y, which is the same as this slope. So like if this slope was 4/3, this slope would be 3/4. They'd be reciprocals of one another. Okay? That makes sense? What are you eating?
Protein bar.
It looked like an ice cream bar from here because of the white, and I was like, he's had an ice cream bar in his backpack for how many hours now?
I was thinking it would be dehydrated or something.
And this gives us what's called the derivative rule for inverse functions. If f and g are inverses of each other, then g prime at b is equal to 1 over f prime at g of b. And the order actually does not matter. Occasionally students are like, well, which one is which? Which one's they're inverses of each other. So this also means that f prime at b is equal to 1 over g prime of f of b. Same thing. So let's verify the derivative rule for inverse functions for f being x squared and g being the square root of x. All right, so let's start with g just so that we're starting the same way our original one did. So g prime at x is 1/2 x to the negative 1/2 power, right? Which is 1 over 2 square roots of x. Now, 1 over f prime of g of x is going to be 1 over f prime of the square root of x. What is, I'm going to do this over here, what is f prime of x equal to in this case? 2x. So this will be 1 over f prime at the square root of x. Oh, hey, look at that. They are equivalent to one another. That makes sense? Aiden's looking at it like he doesn't believe me quite yet.
No, it
Which
makes
is
sense. I don't know if I could independently repeat it, but
no, and that's totally fair. We're going to practice getting you to where you can independently repeat, not for general functions, but I just wanted to show you that it does indeed work. By the way, the question should be, well, I mean, who cares? I can take the derivative of both of these without using this rule. All right? So here's an example of one where it's like, oh, this is why I care. So if I let f of x be equal to 4x cubed minus 2x plus 1, and let f inverse denote the inverse of f of x, find f inverse prime at 3. You're like, okay. First of all, most students don't like that they call this f inverse. They're like, the rule says f and g, and I have little tiny blinders on and I can't see anything else. If you need to call it f and g, great. So think of this as being g, and think of this then as being g prime at 3. If that's helpful to you, and for many of you, especially at the beginning, it will be, great. Go ahead and do that. Here's the reason why it's important. Do I know the function for g? No. So taking its derivative, well, I don't know what the function is. And think about, just for a second, putting y in the place of f of x. Don't worry about writing this down. And how did you normally find inverses? Well, you switched the variable and solved, right? Tell me how you're going to solve that for y. Sam's got something sassy to say.
You can.
I think that you can, but I don't know what it is. I think you'd have to subtract the 1 and then factor and then do something else.
2y, you get 2y and 2a cubed minus 1. And then
Yeah. Even if you can, it's ugly, right? So here's the deal. We're trying to find f inverse prime at 3. Or if you prefer, let's do g prime at 3. G prime at 3 is going to be 1 over f prime of g of 3. And this is where students will have an objection. They'll go, wait a minute, we don't know an equation for g of x. How the heck am I supposed to find g at 3? Well, the answer is actually kind of simple. If we want to know g of 3, we want to know where is f of x equal to 3. And when they do this to you, it's either a calculator active problem or it's one where, as in this one, pick a couple of small integers and try them and you'll find it pretty quickly. What is an x value that's going to make this equal to 3?
1.
Yep. That means that f at 1 equals 3, which means that g of 3 is 1. That's the step that causes students more grief than anything else. Okay? Well, now I need to know, well, what is f prime of x? Well, that we're pretty good at this point. 12x squared minus 2. F prime at g of 3 is f prime at 1, which is 10. So that's 1/10. Okay? So you have to start off with that derivative rule for inverse functions and then kind of peel your way through it. Let's look at this next one, which is actually slightly easier. It says, let f be the function defined by f of x is equal to x cubed minus x. Again, really horrible to try to find an inverse function for that. If g of x is the inverse of f of x and g of 0 is equal to 1, what's the value of g prime at 0? I always start with what I want to know. G prime at 0 is going to be equal to 1 over f prime of g of 0. And on this one, they went ahead and told you g of 0 is 1. F prime of x is 3x squared minus 1. F prime of g of 0 is equal to f prime at 1, which is 2. So this is a half.
It's like a, I don't know how to describe it, like, just like falls into place.
It falls into place really nicely if you do them correctly. And as far as on the AP exam goes, I'm not allowed to talk to students about multiple choice questions, so I don't know how often this comes up. I've never seen it on a free response question. I assume it still comes up occasionally as a multiple choice, but I don't know.
You
It,
can't talk to us about that.
no. After the AP exam, we can freely discuss after 48 hours any of the free response questions you want to, but I'm not allowed to talk to you about anything about the multiple choice questions. And part of the reason why is one of the ways that they benchmark how this year's group does compared to ones in the past is some of the multiple choice items are the same as they were last year. And they compare those. And that's partly how they decide the cut scores. So like anyone who tells you you have to get exactly this many points on an AP exam to get a 3, they're wrong. Because it changes from year to year. Because they compare, is this year's group better on the like items or worse on the like items? They do a lot of statistical things to figure out, where should the cut scores be. Okay. Last page, I think that's the last example. Yeah. I kind of like questions like this because if you know what you're doing, it doesn't take as much work even as the last couple did. It also has some distractors in it. They give you more information than you actually need. I like that also. Maybe not as a student, but as a teacher I do. So let G be a differentiable function such that G of 2 is 4, G of 4 is 3, G prime of 2 is 1/3, and G prime at 4 is 5. The function h is differentiable, and h of x is G's inverse. What is the value of h prime at 4? All right. It's exactly the same as we started all these other ones. H prime at 4 is going to be 1 over G prime of h of 4. H at 4 is 3. So that's 1 over G prime at 3. Oh, sorry. So G of 4 is 3. If G of 4 is 3, that means that H of 3 is 4. But do I really want H of 3? No, I want H of 4. Oh, hey, look at that. If G of 2 is 4, then H of 4 is 2. And that's where people get turned around on this. You've got to know that rule about derivatives. So this is 1 over 1/3 is 3. Yeah, if you know what you're doing, then this is very much what I call a light bulb question. It's either on or it's off. There's no in between. Okay? And again, the substitute should give you this worksheet tomorrow.